I am Sheetal Gundre. Welcome you all for this expert talk. First, with the permission of our respected Honorable Principal, Dr. U.J. Kahalekar sir, I take the opportunity to start this session. So today we are pleased to welcome our speaker, Mr. Sachin Gorlevar sir from Pune. And today he will be sharing with us his expert opinion on role of robotics in product development. He is currently working in Griffin Robotics Private Limited as a Chief Robotics Officer. Griffin Robotics work in the space of AI, robotics and inspections. He has spent more than 17 years in the field of robotics. He had been involved in all the phases of robotics, right from robot R&D, robot application development to robotics implementation at shop floor. His core expertise lies in robotics application development. He had been a part of Bajaj Auto Limited, Dr. Reddy's Lab, Tata Enterprise, and Griffin Robotics and implemented robotics in a variety of sectors like automotive, pharma, FMCG, software, etc. So I welcome Sir and thank you him for sparing time to deliver this talk. Without any further delay, I request Sir to proceed and start his talk. Over to you, Sir.
Thanks, Sheetal Madam. So kind of you.
Thank you, sir.
For introducing me in such a good way. Yeah.
Thank
Good morning.
you, sir.
Yeah, I think all of them are on mute. So I just want Sheetal ma'am, like this will be a interactive session, or I just need to deliver the lecture?
Sir, first you deliver the lecture. Afterwards, if anyone students having any questions, then we will cover that session, sir.
So what I suggest is I will start delivering the topic, and meantime, if any student has any question, they can type in a chat box so that I can explain them on the spot.
Okay, sir.
Yeah.
Okay, sir.
Just give me. Yeah, tell me, ma'am.
No, sir, just I want to confirm whether the students of robotics, Baha and Tech Electra had joined. Zoha, can you please tell me? Okay. Okay, sir. You can start, sir.
Should I make my camera on?
Yes, sir. Yes.
Yeah, so good morning once again, everyone. This is Sachin Kumar from Griffin Robotics. And I have almost spent my entire life in robotics. And let's have some fruitful discussion today. Okay. Give me some time. I'll just share my screen. I just want to present something. Is my screen visible?
Yes, sir. Visible.
Just a minute. Yeah. So today we will be speaking about the role of robotic in a product development, right? So to start with, we should be clear about what exactly is the product development and what are the phases in the product development. So if you see, product development is a vast process, and it starts with idea creation. So a lot of ideas are generated during the session, or the vision is set and ideas are generated as per that. But the thing is, there are many ideas. This is the first phase of idea creation. Second is screening of ideas, like we may sort out or we may screen some ideas, like if there are 10 ideas generated, so we may drop down the 8 and we find like 2 ideas are more suitable. So instead of spending time on all the 10, we may choose 2 ideas which are very much near to our vision or very much near to our target. So that we will screen. Okay. So once screening is done, we move to concept development. Okay. Where we give some shape to the idea on paper. So most probably the concept development happens on a paper. If it is, let us take an example of a product like TV is a product. So initially how it will be looking, what features it will have, and how the things will go in TV. So all this will happen on a software part. So concept development is the phase where we give some shape to our ideas on software or on paper. Okay. So once we have done this, the next stage is product development. Product development, you can call it as a prototyping, where you convert your ideas from paper to a reality. It may be rapid prototyping using 3D printers or machining stuff, right? So product development is very much similar to prototyping. So once you've done this, you take some trials of the product, you check whether your product is workable or not. And once you finish this cycle from idea creation to product development, the very important cycle is commercialization and the rollout, right? Commercialization and rollout means like, see, after all, it is a business. No one does the business, or no one does anything for a charity. Majority of people do it for a business, and until and unless it is commercially successful, you will not be able to get the benefit out of it. So one of the very important factor is commercialization and rollout. With my experience, I could say like there are very exciting people who comes with a lot of ideas. They do a very good conceptualization. They do a very good prototyping. Everything is fine, but somehow they fail to commercialize it. So most of the ideas or most of the stuff failed in the commercialization. So very important aspect of product development is the commercialization. So being an engineer, we will be trying to focus what exactly is the commercialization and rollout. So commercialization and rollout comprises of 4 factors, which includes production of the equipment or product, what we have done, distribution of the product. Distribution means like packaging and all that stuff, how it will reach from your factory to the customer. Marketing of course everyone knows. Sales and customer support. So these are the 4 pillars which will make our product successful. And if you see, like, distribution falls into logistic part or management part. Marketing and sales is all about administration, like MBAs and all that stuff. So we being an engineer, we will be very much focused on how to improve the production, or how to focus on a production to make it more successful. So throughout this lecture, we will be focusing on the production part. So production is very simple to define. Like, production is the process of combining various material inputs and immaterial inputs, plans, know-how, in order to make something for consumption. Like, we get a lot of raw material, we process it and make some meaningful product. So this is the very simple definition of production. Now, how we can say like the production is successful, or we are doing a good production. So the parameter on which we measure the production is like productivity, whether our productivity is high or not. Quality, how we are making or how we are ensuring the consistent quality. Cost, of course, during the manufacturing, how is the cost involved into it, like whether our costs are under control. Delivery means like whatever is coming into the factory, it should go out of the factory in the same way. Safety, during our production, during we do our production, we have to make sure like it has to be at most safe environment to work. Okay, so safety will automatically boost the morale of the employee, and this will also help to boost the production. So these are the 5 pillars where we can count, or where we can quantify our production, or where we can quantify whether our production is up to the mark or not. So what I will do is I will take each of the example, for example, productivity or quality, cost, delivery, safety, and I will explain how is the conventional process for productivity, and how the robotics is going to make a difference when we move from a productive conventional method to a robotic process, right? Till this point, anyone have any doubt?
Students, you may unmute yourself and you can put your answers in chat box.
Yeah. Right. So what I'll do, I'll move to the other part. Now productivity, like it's very simple. Productivity in manufacturing is measures the number of units produced or net sale relative to employee labor hours. Okay. Like for example, if 10 people are working in the factory, so what is the output? How much is the product manufactured in a day or in an hour? So this is what is the definition of productivity. Now, moving to the what I will do, I'll take a very typical, what you can say example where where everyone can connect, like everyone can relate. Uh, Most of the students are from which branch, ma'am? Mechanical or electronics? Let me consider like it's a common branch, right? So when you see the manufacturing setup, for example, if you want to machine something and you want to do a machining work, so basically the setup is like there is input, there is machine, and there is output, and the fourth factor is a person. So what person is doing is he is taking the material from the input, he is putting into the machine manually. Okay. And after that, after the machining finished, he picked the material and put it to the output bin. So this is how the typical machining center does the work. Okay. Now if you go to the statistic, like if you want to know like how productive it is. Okay, so let us take an example. The total working hour, usually in the Indian standard, the factories work in 3 shifts where each shift comprises of the 8 hours. So you can say like total working time is 480 minutes. Okay. And typically we require the break. For example, normally as per Indian standards, there are 2 breaks, tea break and 1 lunch break. Okay. So 60 minutes is gone into it, like 10 minutes, 40 minutes, 10 minutes. Okay. So now the available time with us for the working is 420 minutes. Now there are shift changes losses, like when one shift ends, another shift starts. Some time is consumed into it. There is like 5 minutes at the start of the shift and 5 minutes at the end of the shift, right? So losses total 10 minutes. So now we are effectively left with 410 minutes. Okay. And efficiency, like if you see like humans, we are humans, so we cannot work like a machine continuously because we have a efficiency, we get tired. When in morning we are more productive, but after we have our lunch, you see like the efficiency will slightly go down, and at the end of the shift everyone is like wants to go home, and efficiency again drop down. So for a standard calculation, I have considered like the humans are working at the 85% of efficiency. Okay. So the productive time is only 348 minutes. So if you see, the target is 480 minutes, but actual we are using is actual usable time we are left with is 348 minutes. Okay. So output efficiency, if you calculate in percentage, it is coming out to be 72.5%. Okay. Now this is a typical scenario where you can see like the efficiency we are getting out to be 72.5% when we are working with the human beings or operator. Okay. Now, what we have done is we have implemented the robotic for this. Okay. The previous setup is slightly modified. Okay. And we have added the buffer input conveyor and the buffer output conveyor. Buffer means like we have uh, the largest break is 40 minutes. Okay. So you should feed the robot the input components which will last for 40 minutes. And there should be a space where the finished components will be kept because this cell will be running manless. So on the left side, I have given the graphical representation. On the right side, you can see there is a robot which there are the input trays, there is a machine and there is output tray. So this is how it is. Now let us see the calculation, like how exactly it has helped us. So effective working time was 480 minutes. Total working time is allotted for a shift is 480 minutes. We don't take robot don't take any break. Okay, so there is no loss in tea break time. Okay, robot can work across the shifts without stoppage, so there is no shift change loss. Okay, of course robot will have the higher efficiency compared to the human being. So let us consider like robots are working at 95% efficiency. So the total effective working time available for us in the shift is 456 456 minutes. Okay, so available time is 480 minutes, actual time is 456 minutes. Okay, the output percentage, if you calculate, it is 95%. So obviously when we go for robotics, so we are going to get a huge amount of production benefit, like our production is going to be increased. Now let us compare both the scenario. For manual operation, it was 72.5. For the robotic operation, it is 95%. The productivity is increased by 22.5%. This is a huge amount of increase in productivity. For example, if your plant is designed to manufacture 100 units per day, and if it is operated by the human beings or operator, you will get approximately 72 to 73 parts. Okay, but if you go for robotics, it will give you 95 parts. Okay, so there's a good amount of activity increase. Okay, on the other hand, if you see, if you have a 5 machines for that, so the productivity out of 5 machines, so if you see like one of the machine can be spare. So when you want to it to be operated by the human beings or manual operator, you may require 5 machines, but if you want robotics, so you may require 4 machines because your productivity is increased. So these are the benefits of implementing robotics in the production environment to increase the productivity. Any doubts so far? You can write in chat box. Are you getting this? Can we make this session interactive? Because then I will also enjoy it. Okay. So now let us move to the next topic, which is quality. See, the quality is very important factor. Okay. Let us take a scenario like you have bought a mixer. Okay, and it was working good for the 2 days, and on the third day it has stopped working. Okay, so will you buy this mixer from the same company once again? No. What will happen, like this will give a bad marketing. You will discuss this mixer issue with your friends, and then your friends will also try to avoid that brand, and ultimately what happened, the sales drop down, your business start turning into loss, your customer will start losing faith into you. Okay, and your brand get damaged. So what do you think, like why we use Apple phone, why we don't argue, like why we are not waiting for the discounts on the Apple phone? Everyone wants Apple phone because of its quality, the build quality, the operation quality. They are spending lot to maintain the quality. So that is why they are a very successful brand. So in order to make any product very successful, quality is the prime most important. So let us see like what exactly is quality is. Quality is like manufacturing quality is conformance to specification. Quality of design and conformance to specification provide the fundamental basics for managing operation to produce quality product. The cost of poor manufacturing quality is high. Like you may have a direct impact on your sales. Okay, if you compromised on quality, right? Now, what we will do is I will continue with the previous example. Okay. And I will help you understand like what exactly is the quality, how it gets hampered. Okay. Yeah. So let us take an example where the previous example we have seen the machine tending operation. So if you consider like you have an cylindrical component, okay, and it's very precision component. Okay. So the normal practice will be whenever you receive the component from your supplier, the quality has to be checked, diameter of the component. Whenever you are doing the machining, so after machining, your quality need to be checked. Okay. Because consider like this is very hard component and your tool is continuously getting weird. Okay, so you need to give the tool wear compensation in between at the rate of say 20 components. So once you start machining, so after 20 components, the tool wear is such a way like your put quality is out of tolerance, not near the tolerance. So you need to go and give the tool wear compensation. So this require a lot of manual intervention. Now let us see the impact. If you miss inspecting the input component, like from the when you receive the component from the supplier and you fail to inspect, it may result in a tool damage. For example, the required OD is 20 and the supplier has given 21. Okay, but your machine is your machine what you can say the throughput or the approach speed is considering 20, so it will get damaged when it comes 21 because that is not considered. So if the tool gets damaged, the cost is very high. That will get distributed among all the components. Okay. Now, if you fail or there is always chance, like whenever the output component is coming out of the machine, you need to check it. Okay. Because what happens if there is a tool breakage happens and or tool chipping happens and your output component is not consistent. If you're not checking it, uh, whatever components you are producing out of it after that damage, okay, so that will be all rejected and it is a huge loss. Okay. Sometimes what happen like you forgot to give the tool wear compensation, then that is real chaos at the shop floor because everything is getting rejected. So this is a scenario where now just to summarize the scenario, it is very important to check the input quality. It is very important to check the output quality. Okay. And it is very important to give the tool wear compensation to the machine. Now let us see how we take care of this when we move to the automation. This is exactly the same cell which we have discussed earlier. I have done slight modification into it, right? Here I have added the two gauges. One is in this green color is a gauge, input gauge and the output gauge. Now you receive the material from the supplier, we put it into the buffer, we get this into the input. Now what robot is doing is robot is picking the part, placing into the gauge. Okay. Now if the part is not into the tolerance or not into the acceptable range, the robot will reject the part. Robot will not put into the machine. Okay. So here what we have done is we have ensured whatever parts we are putting into machine are checked. Okay. So our machine doesn't get damaged and our cost is well within control. Now, after the machining happens, we take the output component, again we put in a gauge and we will see whether the machining is within tolerance or not. Okay. Now what happened like it is a very hard component and you need to give a tool wear compensation after every 20 minutes. So this data is recorded and when it approaches towards the tolerance, the robot will automatically give the tool wear compensation to the machine. Okay. And this is how you are completely automating the cell, and you don't have to worry about damages to the machine or the output quality. Your output quality is 100% inspected. And once your part quality is good, ultimately your product quality will be good. So this is how the robots can help it to maintain the quality. Okay. Now the advantages of this is consistent quality, zero manual intervention, 100% quality inspection, increased tool life, and a manless operation. Yeah. Anyone have any doubts or any questions till now? I'll be very happy to answer your questions. Even you can write in the chat box also.
If any student is having a question, please you can unmute yourself.
Yeah, let us have this session interactive because
Yeah. Yes, sir.
I'll also come to know like what exactly you're looking for or what are the questions in your mind. This will help me also like to improve on the next time. Like I can stress on that point in some of the next presentations.
Yes, sir. Yes. Actually, the students who are working in robotics, they might,
Hello, sir.
I think they might having
Can I
some
ask?
questions in their mind regarding this
Yeah.
robotics. Okay, sir.
Okay, I'll continue.
Yes, sir.
Yeah. Next thing is a cost. Okay, now we have seen the productivity, we have seen the quality. Now it is turn of cost. Okay, till now what we have done is we have seen the robotics for material handling. There are majorly robotics is used in two ways. One is the process industry and another is the material handling. So till now we have seen the material handling. Now we will see some of the examples from the process industry. Process industry means robot is not only handling the material, but robot is helping the process. Process means welding, sealant application, painting. So these are the processes which are done by robots. Okay. Now, cost is like everyone knows, like manufacturing costs are the cost incurred during the production of the product. The cost include cost of direct material, direct labor, or the manufacturing overheads. Okay. Now, I will try to explain you with one example, right? So here I have taken the example of a sealant application. Are you aware of sealant, which is prominently used in automotive industry? Okay, I'll explain you the sealant. What exactly is a sealant? In automotive industry, especially in four-wheeler, okay, when you join the two parts, two pressed part, sheet metal parts with each other, okay, in between we are using the sealant. The there are two major cause for it. First one is your whenever you are driving the vehicle, it will not make a sound because this sealant will act as a damping agent in between the two sheets. Okay, and another part is like it will avoid water or resistive agent to getting into the deep of the sheet metals. Okay, so these are the two causes where why we use the sealant. Most commonly used in four-wheeler industry, not even in two-wheeler industry, four-wheeler industry. Okay. Now, when you see, it is very much simpler to drawing a mehndi on your hand, right? So on the right side, what you can see is the white color on the red part is a sealant. Okay. Now here itself, you can see when the human is applying the sealant, there are a lot of issues he is facing. Issues is like getting the even bead, that is the requirement of the process. Like if the bead is the diameter of the sealant, if the requirement is of 5 mm of sealant, it has to be a 5 mm. But if you are putting it manually, the bead is directly proportional to your speed, and no way the human can have the very constant speed because we are human beings. So it may not be possible to achieve the constant speed with the hands. Okay, so the bead diameter will vary. Okay, we are also not able to follow the exact path because every time our path their hand may shake, or at the end of the ship we may feel very much tired, and we may not able to follow the path. So what is happening is there is a loss of sealant. So there is a calculation. For example, if it is estimated to like 100 gram of sealant per vehicle, and if you do it manually, it is never 100 gram, it is 120 gram, 150 gram, because a lot of sealant is wastage because of uneven bed, because of not a straight path, we follow the shaky path. Okay, so if you calculate the consumption of sealant, okay, so it is always going to be higher in case of manual operation. Okay. Now let us see the benefit when we do it with the robot. Yeah, so on the right side you can see, I have not shown the robot, but yes, you can see the gun, and you can see the quality of sealant. It is very even, it is very within the part, within the straight line. So when you go for the robotics, your consumption of sealant is highly reduced. That is the cost. For example, if it is 100 rupees on per vehicle, initially you were spending 150 rupees. Now the cost has been reduced, and this is like for every car. So if you are manufacturing 10,000 vehicles per day, you can imagine the cost saved into it. So when it comes to the mass, of course, you have to go with the robotic procedures in the sealant application. This will help you to save a lot of consumable. So this contributes to the cost. So when you apply robotics in the process industry, it is definitely going to help you to reduce the consumable cost. Any questions till now? Yeah, sir, what is the process to maintain the efficiency of robot while production? When we say robot is 100% efficient, like once you do the programming, it will keep on continuously working, but still we consider like 95% efficiency or 98% efficiency. Why? Because it also should get the input component. If the input components are not fed, or if there is a gap for feeding the input component, robot has to be idle because he doesn't have any stuff to work. Okay, so and the minor stoppages like it doesn't have the component, there is a line stoppage or conveyor issues or fault in the conveyor or anything. So with this thing, we consider it to be a 95% efficient. But yes, if everything is working fine and idle condition, it's 100%. So Sudhanshu Doble, na? Yeah. Okay, one more question from Gaurang Kulkarni. Generally, which kind of material are used while making robot? What factors are considered? See, robot basically there are three major parts. All robot has servo motors. They have absolute encoders and gearbox and castings, aluminum castings. And manufacturing of robot is very highly precision job. Okay, so what I'll do at the end of the session, I will also brief you about the statistic of robotics, how much robots are manufactured across the world, which country uses the how much quantity, and where does India stands into it, right? Sir, is it possible for small scale industry to automate? Yes, definitely. See, automation basically is decided on ROI, okay, return on investment. And if the small scale industry is into mass manufacturing, So if we properly engineer the robot, of course, there will be an initial capital investment, but on the long run, if the ROI is coming out to be 2 years or 1.5 years, so it definitely makes sense for the small scale industry to introduce automation. Basically depends upon ROI. Yeah.
Hello, sir.
Yeah.
Can I ask one question?
Yes, please, please.
Sir, actually, we built the robots, but when we are going to reduce the time, then we lost our accuracy. So,
Yeah.
how to overcome this problem?
See, when we are doing a conceptualization of production line, okay, that time only what we do is we calculate the cycle times. Means, for example, the cycle time is very short. We go for parallel quantities. Okay, two cells or three cells. Depending upon this, we call as line balancing. So very initial stage, as design stage itself, we take care what will be the cycle time. And of course, accuracy are maintained. Yeah. Did I answer your question, or do you require more inputs on it?
Yes, sir. Yes, I got that. And actually, sir, I am little confused. Then, what is the difference between robotics and automation? Like we build the robot and then we thought to make that robot automate. So, what is basically difference between robotics and automation?
Yeah. So if you see robotics, as per International Federation of Robotics, they have defined the definition of robotics. If you are using more than 3 axes in order to achieve a path, okay, that is called as a robot. Robot falls into the many category. For example, if it is 3 axes, we call it as a Cartesian robot. If it is 4 axes, we call it as a SCARA robot. If it is 5, 6 axes, we call it as a articulated robot. Okay. And this robot is very much similar. These robots are helping us to like hands. Okay. But only robot cannot help us. Okay. Because if I buy the robot, it is not going to improve my productivity, or it is not helping me into keeping the consistent quality, because I need to integrate that robot, okay, with my existing system. And in integration, you may require PLC for communicating between the robot and your machine. You may require grippers, where you may need to have the grippers on the robot so that it can catch the component. Okay. You may need to have pneumatics. You may need to have conveyors. You may need to have lot of stuff, operator interface. So when this is called as a automation, okay, and this combine is called as a robotics and automation. So there is automation possible without robot also, because if it is normal pick and place, we can use normal pneumatic stuff. So that is the automation. And if you use robot for automation, it's called the robotic and automation. Does it make sense?
Yes, sir.
Yeah, thanks. What is role of machine learning in robotics? Yeah, very interesting. So currently I'm working a lot on artificial intelligence. So what I'm trying to do is I'm trying to combine artificial intelligence with robotics. I'll just give you the example. Okay. For example, uh, if you have for example, says you have what you can say. Uh, you have the inputs for the robot, means input material, okay, and input material is consistent means you are handling the biscuits, for example, okay. And you know like how the biscuit will come at the input, okay, and you may have the normal camera to identify the location of biscuit, and the robot will come and pick the biscuit. So this is a regular image processing problem, okay. But what happens if there is a situation like the biscuit is not consistent, there it can be biscuit, it can be chocolate, it can be any color, okay, or any object. In that case, we can implement machine learning to identify that object based on the data, okay, and give the prediction to the robot like what exactly it is and from where to pick. And this is going in a big way. I will just give a small example, another example which I have did. So what happened, I have a small robot at my home, okay, and I want to my kid is 11 years and another kid is 4 years, okay. So the daughter of 4 years old is very curious and want to play tic-tac-toe. You must be aware of tic-tac-toe, the cross and the zeros, okay. So what I have done is I have given the pen to the robot, and robot has drawn the grid, 3 by 3 grid, okay, and robot will prompt the player to play. So player can play either 0 or x, and after that robot is playing, okay. After that again player plays and again robot plays. So this is how it continues. But now the catch here is, if you go with the regular image processing, you have to draw the exact circle or exact x, okay. But when humans are writing x or 0, okay, it the shape may vary because we are human. If my kids write, it will be slightly different when I write, okay. So in this case, what I have done, I have created a model, okay, where I have taught the robot or the algorithm what exactly is 0, okay, and what are the variations of 0. So I have captured, like, all of my family has written zeros number of time, 50. We have captured the images of 50 zeros and we trained the algorithm, okay. So it was working, okay, okay. So because we have taught him to read the 0, but what happened, sometime it was malfunctioning. Then I came to know, okay, lighting situation also varies. So I have taught the robot with different variation of lighting, okay. It was working for some time, again it was not working. So I came to know, like, the ink of my pen is also a problem, because when the pen is new it is dark, and when I keep on using the pen it becomes faint. So I again train the robot for light pens also. So this is what is training, this is what is machine learning, where you train the robot to learn the activities, and after doing all these activities, yes, the now the robot is working perfectly. It is able to perfectly identify the zeros and x, okay. But I don't know the future problem. If something new condition arrives, I need to again train the robot. So this is what is the difference between conventional stuff and the artificial intelligence. Yeah, hope I answered the machine learning question. Yeah, right. Another question I have is how the accuracy of the robot is calibrated. Okay, I have my method to check whether the robot is accurate or not. Okay, there are two terminologies: accuracy and repeatability. Are you aware of that? You should be aware of that. Yeah. So I'll just answer the question how the accuracy of robot are calibrated. So these are factory calibrated. Okay. When you get the robot, it is calibrated, and along with that you get the values, because the encoder values along with the robot. If in some case the calibration goes, then you can enter that values. Calibration goes means every robot is battery powered. There is a small 2 or 3 batteries which will retain the position of the robot, okay. Now my way of checking whether the robot is accurate or not, what I will do is I will ask the robot to draw the circle. Okay. And if that is a perfect circle, I'll just measure the across diameters. Okay. If that is perfect, then the robot is perfect. If robot is not accurate, then that circle will be slightly oval or some different shape. Yeah. So this is how I check whether robots are accurate or not. But they are mostly factory calibrated. Was I able to answer the question, or you may Parth? Parth. Okay. Take the next question. Sir, what is the best structure to manufacture a robot? Which steps should be more focus on? Achha, which steps should be more focus on? Majorly when you are manufacturing the structure, you need to have the dynamic analysis. So whether the structure will survive the dynamics. If you are designing the robot for to move 4 meters per second, if that is the speed you are looking for, then your structure should support that speed. So lot of software plays a role, like SolidWorks, which help ANSYS. So these are the software which plays role to check whether it suffices or not structure. Adams is there, one of the software. Yeah. Another question. Okay. Sir, what is the path process followed while doing the maintenance or to identify the fault? Raj Shekhar. Robot, see, in robot, we have only one critical part, which is gearbox. For if it is an articulate robot, it has 6 gearboxes. Okay, some of them may be planetary, some of them may be harmonic. The very prime requirement of that is greasing. Okay, so robot manufacturer gives us the direction, like what exactly should be the frequency of greasing, and we need to follow that. That is the only way. If you do that properly, your robot is not going to go in error. I have been into this industry since last many years. I have not seen robot going into a problem. I have seen the automation going into a problem. Yeah, I have one more question. While manufacturing robots, there is high chance of human error, which will affect robot efficiency. How human errors can be eliminated? See, when you get into the manufacture, when you decide to manufacturing something, you define the tolerances. Okay, and at the same time you also establish the mechanism to achieve the tolerances. Like I have given to the example when we were talking about quality. In that case, we have given the gauge. Okay, so even if robot is not there, and even if you give the gauge, you will be able to maintain the consistent quality. Okay, you may not able to improve the productivity, but you may able to get the quality. So that is how, with having the proper gauging mechanism, you will be able to achieve the good quality. Does it make sense, Gaurang? Okay, thanks. So, anyone wants to come in? What types of industrial sensors are used in robot? Robot mainly has encoders. That's it. Robot need to know its position or the coordinate. That is the only sensors you can say. Most of them use absolute encoders. Majorly sensor we used when we integrate the robot with our machine. We use sensors like reflective sensors or some normal inductive sensors on the conveyors for part present and all this stuff. Should we move ahead?
Yes, sir. I think questions are over.
Mustaq Sheikh has a very interesting question.
Uh,
Can robotics replace human employment, especially machine operator?
Machine operator. Yeah.
So has computers replaced the bankers, the employees working in bank? No, they have in fact they have taken it to some other level. Okay. So same was the fear when computers were introduced, like everywhere, if everywhere computers are there, okay, what the banking employee or what the other employees who are doing the work manually will happen to them. But if you see, India is an enormous country with lot of consumption. Okay, if we and the bottleneck is manufacturing stuff. Initially, the bottleneck was banking because everything was manual. You need to go to the bank. You need to stand in a queue to submit the money or withdraw the money. But now, if you see, with the help of the computers and the mobile, the bottleneck has been solved. You are getting transaction on your mobile phone. So this is how the business expands. Okay. Now, initially the banks were limited to the maybe metropolitan cities. Now it has reached to the villages. So there is always a scope of improvement. Similarly, manufacturing is the bottleneck right now because there is a lot of consumption. We can, in fact, we can export to the countries. Okay. But we cannot export because we cannot produce. So this is production is the bottleneck. So once you solve this bottleneck, obviously there will be a lot of employment, and then what the thing is, the people will do a quality work. They will not do because human is such a creation, intelligent creation, not made for the mundane work. I hope Mustaq check, does it make sense? Thanks. Yeah. Yeah, so let's move to the next topic. We are talking about delivery, one of the pillar okay, of the production, one of the pillar of production. See, when we say delivery, it is all logistics. Logistics are essential part for providing good customer service on time. If you produce a lot of components and if you are not able to deliver that to the market in time, okay, then that is going to create a problem. Just to give the example, if you see FMCG or foods, right, you have to do a very fast delivery to the customer because they comes with an expiry date. If you are not able to deliver that within time, stipulated time, okay, it may happens like your product may expire in your factory itself because you are not able to deliver. Okay, so manual dispatch is the activity which ensures the speedy delivery. If it is with a human being, we face a lot of challenges. For example, segregation of order, fatigues for box handling, maintaining the FIFO, damages to the boxes. Okay, so these are the common challenges which are faced by the industry, because if there is an order, let us say we are working with a dairy company which is dispatching milk and curd. Okay, if you see the nowadays the packets are same, you need to properly read whether it is a curd or chash or milk, and you need to segregate it before dispatching. Okay, if it is automated process, it comes with a barcode, you can easily segregate without any mistakes. So proper stuff reaches to the proper customer. Okay, so dispatch is the activity or where delivery is important. Okay. So these are the problems like segregation order, fatigue, box handling, maintaining FIFO, damages to the box. And when we implement the robot, okay, we get a lot of benefits. Okay. Accurate segregation based on the, if you can see on the right side, the boxes are with the label, right? So if robot is catering 4 orders at a time and the input channel is only one, so it may any type of material can come in. Okay, so what robot does, takes the box, it shows to the barcode, and it's segregated and it properly placed. So fatigue, speed, and accuracy of dispatch is maintained. So this is how robotics can help in a dispatch activity for a delivery. Safety. See, safety is very important factor, both with the legal laws or industrial laws, factory law, and also with the human beings. We cannot play with the lives of human beings. So robot, if I have a factory and if I have the dangerous working environment, so I will try to implement robot first in the dangerous environment, because humans are important. Okay, we cannot push humans to work in the very dangerous environment. Productivity, quality can be last, but safety is very first for me personally. Okay. So to give a safe environment to the workers is the prime most focus of the industrialist. So let us see how robot plays a role in the safety. What I have done is I have just given the glimpse, okay, and the area where which is unsafe and how it has become safe after implementing the robotics. Take example of welding. Welding is a very harsh, very harsh environment. I have personally seen it. I have experienced it. When you weld, it generates a lot of heat. It generates a lot of fumes. Very difficult to breathe in that environment. Okay. Moreover, they are using argon, carbon dioxide gases. Okay. So it's very unhealthy environment. So also time consuming, quality and lot of stuff is there. So if you implement robotics, okay, so robotics is pushed into the harsh environment, because what will happen, like robot is not going to breathe. So it is not going to impact on him, but we breathe and we have to be away from this type of dangerous environment. So welding is one of the area where robotic is used massively. The country like India, we use robotics mainly in welding area. Painting is one of the area where a lot of uh, dangerous environment, lot of isoethanol prophenol, thinner, paint smell, paint of tiny particles. Okay, so this environment is very dangerous, and people can work in this environment with the PPEs, protective equipments. Okay, personal protective equipments, but they cannot put on this equipment, for example, mask for 8 hours. Okay, so when I was in Bajaj, every painter was allowed to only work for 4 hours in the paint booth. After that, he was given the regular work. So that harsh is the environment. So when after implementation of robotics, yes, of course, this environment, we push robot to the harsh environment and we free the human beings from the dangerous environment. So by implementing robot, paintings can be very much safe. Similarly, other application is spot welding, where spot welding is mostly used in four-wheeler automotive, where they are using the heavy guns. Okay, even though they are tied up to a zero balancer, still it is a fatigue for them to position the gun at the particular point, and you cannot do it for 8 hours. It's a very terrible job. Your muscles will start paining like anything, and robot has made the life easy in this case. Fettling, anyone aware of fettling? So fettling is mostly found in casting area. After casting, the like we do 2 parts mold, and at the joining part there we observe the flashes of the casting. Okay, and normally it is removed by a human being with a grinder. Okay, again a very unsafe. Lot of injuries are happening in that case. Okay, so robot has now developed to take care of fettling also. So fettling is one of the area where robot is used extensively nowadays. Press standing. This is very common application across industry, two-wheeler, four-wheeler. Okay. And very unfortunate thing is a lot of operators who are operating this machine, if you see an average, one hand is cut every month. So this is an average, like in every 1 month, 1 or 2 persons are losing their hands. So why? Because they are stressed for productivity. They are paid on the number of components they produce out of it. And with this, what happened? They try to produce more components. Okay. It is not like that, like press are unsafe. Press are very safe. If you see press, they are coming with dual press buttons. Okay. Dual press buttons, so that they are having two buttons on two sides. So whenever you put the component and when you press simultaneously two buttons, okay, then only the operation will happen. So when you are pressing the two button, automatically it ensures like your hands are out of the press. Okay. But in Indian industry, what happens? They combine the two buttons and they make it one button. Okay. So one hand they are using for loading and unloading, and one hand they are using for making the press on. So going beyond this, sometimes what they do, they use both the hands for loading and unloading, and that button goes at their foot. So they are operating that button by foot, and they are doing loading and unloading by their hands. And it requires a lot of synchronization. Even if someone tap their shoulder from the back side, they may lose the synchro, and that may could end up in accident. So presses are very important. Like we need to have robots in the press. Japanese are very cunning in that what they do is, whatever are the two buttons, we used to give two buttons on the machine, they used to give two buttons on the back. So whenever we are pressing, not only our hands, we are away from the machine. So this is how press tending is the application where robot is contributed hugely. Does it make sense? Molten material handling picture itself suggests how dangerous it is. Okay. Nowadays, it is taken care by robots. So if you see, when we use the robot, we started with the product development, from which we came to know like commercialization and rollout is a very important factor, because that is going to decide the fate of the business. Okay. In order to make a successful commercial rollout, okay, we should have an excellent production system. The production system can be excellent when we have the good quantified results for productivity, quality, cost, safety, delivery. Okay. And when you try to implement robot, I'm not saying like you need to implement everywhere, whichever is the pain point. For example, if the quality is the prime most important, you try to implement robot in quality. If it is FMCG sector, volume are very important because their margins are very less. They have to move with a very high speed. So they have to go for the robotics and automation. Pharma, they have to go for minimum manual intervention, because humans, it's a pharma, it's a medicine, it will heal or kill. Okay. So they cannot afford mistakes in that. So for them, robotics is important from minimum manual intervention perspective, automotive safety perspective. So every different sector has their own problems to solve with robotics. Okay. And when you use the robot, what you have achieved is, you have achieved improved productivity, consistent quality, reduced cost, faster deliveries, safe environment for operator. What is the result? Your business is profitable, your business is scalable, your customer satisfaction with the quality, and you always have the competitive edge on the competitors. Hope everyone is on the same page. I am ready to take some of the questions. Anyone can type on the chat box. I have question from Gaurang Kulkarni. What kind of skills we should focus on, which will help us to work in the automation industry? Gaurang, very, very valid and very important question. Okay. when you say automation, it is a combination of lot of field. It is a combination of mechanical, it is combination of pneumatics, it is combination of controls, it is combination of PLC. Okay, so you have to be a master of one and jack of all in that case. So for every field you should have some knowledge. Okay, so that is when you are versatile, when you are open to get knowledge from different fields. Okay, that is how you will be successful in automation industry. Because if you have only knowledge of mechanical, okay, you will be just supporting the automation, you will not able to lead the automation because you don't know anything of electronics or electrical or PLCs, and that is your blind spot, and over a period of time that will stop your growth. Okay, so you have skills, is attitude is very important. If you have the attitude to learn different technologies, that is what is required in automation. Gaurav, does it make sense? Yeah, any more questions? Okay, I have a question. Surendra, how to decide that any industrial process can be replaced by a robot, or how to decide does that robot make process profitable? See, there are two ways which we call as a greenfield and brownfield. Okay, greenfield is entirely a new stuff. Okay, so your deliverables, for example, what productivity rate you require, how much consistent quality you require, okay, how what is the consumption of material. So based on this factor, if you are able to do this with the human beings or operators, it is perfectly fine. But if you are facing a problem of land, you may need to have a small area, so a compact automation can be helpful. For example, if you want to run the production for 3 shifts, okay, then it becomes very important to get robots, because when you have the humans, it is they work in a shift, then their transport, their canteen, you have to be on your toes for 24/7. Okay, so if the facility is made for three shift, definitely I personally insist like robotics has to be part of that production. So this is all about greenfield. Brownfield, brownfield, like you have a problem statement. Okay. You have a usually in automotive, if you see how it works is you have a warranty meetings. Okay, like we give the warranty of 1 year on the vehicle, and if there are defects or if there is issue in the assembly, so if when we see the warranty, if the warranty for paint damage is faulty paint or paint defects going into the field, and if it is comprises of 20% of complaint, that means that is a serious problem for me. And in that case, even I have a human beings for the inspections, still it is not consistent. Okay, in that case I have to make a decision, like if this is my burning problem, then I have to implement automation for that inspection. So this is how we decide, and of course that will reduce the warranty complaints, and ultimately this will be profitable. Surendra, does it make sense? Yes. So I think till now I have given a fair idea about what exactly are the robots and in which field they are used. Okay, why they are used. Okay, what are the benefits of using the robot. So these are some of the topics we have discussed. Achha, one more question. Shekhar. Sir, can you please elaborate which are new technologies introduced in robotic industry See, ultimately, what we are trying to do in the industry is we have five senses. We have skin, we have tongue for taste, we have nose for smell, we have eyes for seeing, we have a lot of things. Okay. Now, what people are, or what the research labs are doing is they are adding intelligence to the robot. Okay. First thing is robot should have the eyes. Okay. So lot of vision technologies are getting integrated with the robotics. Okay. That is helping robots to make it more intelligent, so he can make his own decision based on the visibility. There are the robots which has a sensitive skin on it. We call it as a collaborative robot. Okay, those robots are sensitive. So when it comes in contact with the human being or any obstruction, they stops. Okay, so this is how, like, but I feel artificial intelligence majorly in image based technologies are going at very high pace. So robotics is largely getting integrated with the vision technologies. Rajshekhar, does it make sense? Thanks. Yeah. Yeah. After discussing a lot on the robotics, you must be what exactly is the scenario of robotics across the world. Okay. So what I will do, I will share some of the facts. There is a agency which is called as International Federation of Robotics, which is governing the growth of robotics into a world. Okay. So this is the sale of worldwide for robotics. Okay. Annually, believe me, it is growing tremendously from last 5 to 6 years. Okay, I have the figures for 2015. It was 2.5 lakhs. 2016 it was 3.04 lakhs. 2017 it was 4 lakhs. 2018 it was 4.2 lakhs. 2019 and 2020 were impacted by COVID. That is why the sale has gone down. But 221 onwards, it is predicted to grow with 13% to 16% CAGR. So this many are the robots which are sold across the globe. Okay. Now you will be very curious to know which countries consume how much. Okay. So very surprisingly, China is consuming almost more than 30% of whatever is produced across the world. Okay. So China, if you are producing 4 lakhs, from that 4 lakhs, 1.68 lakhs are consumed by China. Then comes Japan, States, Korea, Germany, Italy, and in India, we consume 3,000 to 4,000 robots per annum. Okay. Now you can see the difference. See, we with the population point of view, we can compare with China. We cannot compare with Japan. Okay. China is 1.68 lakhs, and we are only 3.2 3,000. Okay. So we are not even, I think, 1% or 2% of China. So what does this graph indicates me is there is a huge scope of robotics in India. Why the Chinese material is so cheap? Okay. Even if we try to manufacture something in India, again it is becoming very much costly. The thing is, they manufacture in mass volumes with the proper technologies. We have to nowadays. India is still growing, okay, and moving towards this process of adopting the robotics. Now, when I was doing my engineering, there was nothing called as robotics and automation. Nowadays, there are colleges which has BE in robotics and automation. So I am designing syllabus of one of the university, KL University in Karnataka. Board. So I helped that team to bridge the gap between the education and the industry. What exactly is required in industry and what has to be in syllabus. I think that is the roots from where robotics can take a leap. Yeah. So another factor is when you want to see the density of robot. So there is a term or unit which we call as a robot density. When we say robot density, so it is number of robots per 10,000 employees. Okay. So Republican of Korea is highest on it, near about 1,000. Okay. China is 246. Means after every 10,000 employees, they have 246 robots. Okay. World average is 126, and India robot density is 4. It has improved a lot. Initially it was 1. Now it has improved a lot, but still a lot of scope for improvement for Indian industry to implement robotics. Yeah. So with this, I think I'm done. I'm open for the questions. How you guys felt this lecture? Was this adding any value to you, or you can give your feedback? Does it make sense to you, or what would you like to hear?
Hello, students. Is anyone?
Great session, sir. Thanks. So, thanks.
I think all questions has covered. So, shall we conclude session, sir?
Yeah.
Okay, sir.
So you can ask again if anyone has doubt, because this is when I was doing my engineering, we were not having any access to any industrial expert, and I think that would have helped us. So it is a good opportunity for students to interact, get their doubts clear. Very good opportunity for them.
Yes, sir. Yes, definitely.
Gaurav Kulkarni says, "Thank you, sir, for this session. This session made us aware of robotics and automation." Thanks, Gaurav. Sir, did ROS robotics software is developed by industry or it is purchased? See, the purpose of ROS is entirely different. I'll give the example. If you are working on different softwares, okay, this is mainly a mechanical stream. Chitra ma'am,
Yes, sir.
this is mechanical stream or it is combined, like students?
It is combined, sir.
Combined, no? Okay.
Yes,
So
sir.
the ROS, the purpose of ROS is there are a lot of robot manufacturer across the globe, which include Fanuc, Motoman, ABB, GECA, so on. So there are many manufacturers, and what the thing is, all of them have their own programming language, or all of them are having their own structure, architecture, okay, control architecture. So what happens if I develop one of the application with ABB robot? I cannot use the same application with Fanuc robot because Fanuc robot programming is entirely different. So what this International Federation of Robotics has decided is, because of this, lot of cutting edge technologies are limited to the robot manufacturer. They are not open to the industry. So what they have done is they have tried to bring all the development, and they have insisted all the robot manufacturer to come on a common platform which we call as a ROS. So it is not individual property, it is a contribution. Like we have if there are people from software, they must be knowing Python libraries are there, a lot of open source stuff is there. So in that case, people on the forum, GitHub is there. So contribute and develop it. So this is how, but ROS will take a lot of time, because it is beneficial only when all the robot manufacturer has come on the common platform. Yeah, Sudhanshu, does it make sense? Thank you, sir. Great to know about robotics and automation. Yes, ma'am. I think very wonderful lecture and a lot of questions. I like answering most of them. I am not sure like how much I have justice done the justice of questions, but yes, happy to deliver this lecture.
Yes, sir. Thank you, sir. So, uh, we will conclude this session. So
Yeah.
now it's time to vote of thanks. So I, on behalf of Government Engineering College, Aurangabad, would like to express our sincere thanks to our today's expert, Mr. Sachin Gorlevar, sir, for giving such wonderful informative session and also enlightening us on different aspects of robotics that will be dealt in industries. Okay. And also I thank the coordinator of this activity, Dr. Varsha Ratnaparkhe ma'am, who is the in charge of this IIC activity. And finally, I would like to thank all the participants for their active participation. And once again, I would like to say that we all most grateful to Sachin sir. Thank you, sir, for being with us and sparing your valuable time. It is a great pleasure, sir, to hear you. Thank you. Thank you very much, sir.
Thank you, ma'am. Thanks, guys, and all the best for your future.
Thank you, sir.
Thank you.
Share your email ID, sir, in chat box if any student having queries or some needs some guidance from you, then they can contact you on email.
Yes, I am just doing that. People can connect me on LinkedIn also.
Okay, sir.
Yeah, thanks, ma'am.
Thank you, sir. Okay, sir.
Yeah.
Students, please submit the feedback form before leaving the session.